So hello my dear students. So today we will be discussing amines. So this chapter is one of the very important chapter and we have very few topics to be focused more in this chapter. Okay, so I am going to discuss this topic now using few important PYQs of JEE and NEET exam. Okay, now here first question, if you see the correct increasing order of basic strength of following amines. Yes, they will be giving you either aliphatic amines or aromatic amines and they will asking you to find its basic nature order. So how can you do this? It's very easy. First, amines are basic in nature. What I am saying, amines are basic in nature. So the basic nature of amines is because of lone pair electrons present on the nitrogen atom. Okay, so now I can represent aliphatic amines as RNH2 like this. Okay, so these R group can be considered as alkyl group. Let us say if this is alkyl group, then we can say it is aliphatic amine. Okay, so now if it is aromatic ring, something like benzene ring, so I can say these are aromatic amines. Okay, so aliphatic, aromatic. Okay, so now whenever they are asking us to identify which is more basic between aliphatic and aromatic amine, so how can you answer this question? See here, the presence of lone pair is the reason for their basic nature. So if I have a H plus ion like proton, so now the ease of accepting of this H plus ion will decide its basic nature order. Okay, so now here aliphatic amines, this NH2 or lone pair electrons are set free, so they are easily accept this H plus ion when I compare with the aromatic amines, because in aromatic amines their lone pairs involve in the conjugation with the ring pi electrons. So this makes it to be less availability of these lone pair electrons to accept a proton. Therefore aromatic amines are less basic than these aliphatic amines. Hope this story is clear. Now they are asking about the basic strength of given three aromatic amines. So how can you answer this question? How can you answer this question? So just look at here, if the lone pair electron availability is more on this nitrogen, they can easily accept this H plus ion. This is what basic nature now. Now if any electron releasing group is present, for example here we have a methyl group at para position with respect to like amine group. So this group is considered as electron releasing group by its hyperconjugation and plus I effect. We have studied that in the previous GOC concepts and all. Right now, since it is electron releasing group, now it is pushing electrons upwards towards this nitrogen side. So it means the lone pair electrons are now easily accept this H plus ion as they are pushed, like as they are having some back push from this electron releasing group. Right now, so this makes electron releasing groups increases the basic nature of amines. Basic nature of amines, aromatic amines here. Now whereas nitro group is strong electron withdrawing group. So what it will do? It will only withdraw the electrons from the ring. It means it will drag the electrons of the pi electrons of this ring, and as well as this lone pair electrons present on the nitrogen is also dragging towards this electron withdrawing group. Now tell me, is this lone pair electrons available to accept this H plus ion as we seen in the other case? No, right? These are involving in the conjugation and effectively with this ring electron withdrawing group. Therefore that will makes it to be less basic. So electron withdrawing group containing amines are less basic. So electron withdrawing group decreases the basic nature of amines, you can say. So from this explanation, now tell me, third one is more basic, right? After that, which is more basic? See, there is no electron releasing and electron withdrawing group. Therefore it is more basic than the second one, which is having electron withdrawing group. So I can write 3, 1, 2. So where do we have this kind of option? So 3 is more, after 1 and least is 2. So this is the perfect answer for this question. Hope the concept is very clear, and if it is clear, just click on the like button, and if not, you can feel free to ask me in the chat box. Yes. Okay, so now I will be moving forward with one question as a homework for you. Now this is for aliphatic amines I am asking you. So just take this question and answer in the chat box. So I am giving you nitrogen, okay, NH2 group. Now see, NH2 is there. See, we know ammonia means NH3 now. So I am removing one of the hydrogen and replacing with one alkyl group. Let us say I am replacing it with the ethyl group. What I am taking? Ethyl I am taking. So I can say only one carbon is directly attached to this nitrogen. I can say this is primary amine. Okay. So now another one I am writing ethyl group. Now I am writing same, Et means ethyl, and here I have nitrogen. See, only one alkyl group, so I can say primary. If two alkyl groups are there like this, okay, so these two carbons are directly attached to the nitrogen now, so it is called secondary amine. Now I am giving you tertiary amine here. So I want answer for this question. How do you answer these, arrange these based on their basic strength? So which is more basic strength? I want answer for this in both cases, in gaseous phase I can say, in gas phase you can write, and also in aqueous or liquid phase. In the aqueous phase or aqueous medium you can consider. So what is the basic nature order for these ethyl amines? I want answer for these from your side. Hope it is clear and you can able to answer this, and if not, just tell me, I will explain this. Okay, next, the product formed by the reaction of an aldehyde with primary amine. So tell me, what is the structure of amine here we have? So amine looks something like this now. Primary amine they mentioned, so you can take RNH2. I just now told you, if only one alkyl group is attached to the nitrogen, you can call it as primary amine. Now that is reacting with aldehyde. So write R. What is the aldehyde general form? I can represent it like this right now. So to the carbonyl carbon, at least only one carbon and at least one hydrogen directly attached. See, it should contain something like this, C double bond OH. If this group is present, I can consider it as aldehyde. So here we have aldehyde group right now. So now upon reaction between these two things, what happens? Now look at here, what is the reactive site? See here, the pi bond between carbon and oxygen is polarized towards oxygen as it is having more electron negativity of oxygen is more, creates electron deficiency on carbon right now. And now this nitrogen have lone pair electrons, so it can act as a nucleophile now. So this nucleophile attacks at this electron deficient carbon, therefore we are getting a nucleophilic addition reaction kind of product right now. So now upon final reaction, what happens is elimination of this oxygen and these hydrogens, two hydrogen, like water elimination takes place and gives us something like this, R H double bond N with one R group. So these are called nitrogen with carbon having sp2 hybridization. So this kind of thing is there, means we should call it as imines. What is that? Imines. So do we have any option? See carbon nitrogen single bond you can call amine, carbon nitrogen double bond means you can call it as imines. Okay, so there is no option or the answer as imines in the options, but you know Schiff's base, these imines are also called as Schiff's bases. So here we have imines, so that is nothing but option number 3, which is Schiff's base, is a perfect answer for this question. Hope it is also clear right now. Yes. Now I am looking into the chat box. If you have any concerns and anything to be specially discussed here, you can write in the chat box. I will discuss that and you can feel free to express that. Yes. Let me go forward. Yes. Okay. I hope it is clear. Imines are also called as Schiff's bases. This is a line you should remember so that you will get the perfect answer. Okay. Now I will be moving forward with one more question. Identify 3 in the reaction. See, these 3 we need to identify. How can we identify these? Just look. Here we have CH3NH2 with NaNO2 in acidic medium. So this process is called diazotization. What is that? Diazotization. Okay. So diazotization. Sai, please look at here first. See, diazotization means what? So amine group is there now, NH2 is there now. So this nitrogen and this NO2 will be forms a compound of this kind. See, it will form a compound of this. So identifying the reactive site is more important here. So it will become N2 plus. So this process is called what? Diazotization. Okay. After this, so here we got 1. Okay. So now we need to treat this with water in heating condition. So we know N2 gas, nitrogen gas is highly stable gas now. So whenever we are heating it, so nitrogen gas escapes from heat. It goes out from there. So now there happens nucleophilic substitution reaction, because N2 is going, aromatic nucleophilic substitution reaction is taking place. So N2 is going along by taking along this sigma bond with it, right now. So the lone pair electrons of this oxygen will attach here, substitution takes place, and we will get a product called here phenol, like this. Phenol derivative we got right now. So this is our second product formed in the reaction. And then next we have chloroform. So chloroform in basic medium like KOH upon heating. This is a condition mentioned. Now what you can able to understand, a very important reaction you have studied in alcohols, phenols, ethers. So what is that? So chloroform, phenol upon treating with chloroform in basic medium, we will get salicylaldehyde as a product. What is the name of that reaction? We are calling it as what? We are calling it as Rearrangement reaction right now. So that is what the product formed here. So what happens here? So whenever you are treating CHCl3 with like basic medium, first this will generate an intermediate called CCl2. Dichlorocarbene is the intermediate involved in the Rearrangement reaction. So this will react with this this phenol derivative and forms a product. Since I told you this is an electrophile, so reaction takes place at what site? See, OH group is there now. So this is a strong electron releasing group, activates the ring at this ortho positions and at this para positions, but already para position is occupied by methyl group now. So now the reaction can take place at this ortho position, either this place or at this place, and we will get a aldehyde group over there like this. Okay, aldehyde group over there, something like this. Okay. Okay, so what is the product formed here finally? So I am writing phenol, ortho position aldehyde, and methyl group as it is. So this is a product formed. Now look at the option. Do we have any options of this kind? Yes, we have somewhere. Yes. So here if you look at the first option, yes, this is our option for this particular question. Hope it is clear. Yes. If the question's discussion is really going well, just click on the like button and you can express in the chat box. Yes. Right? Next. Here we have one more question. Which of the following gives Friedel-Crafts reaction? So what is Friedel-Crafts reaction? It is an example of electrophilic substitution reaction right now. So what happens in Friedel-Crafts reaction? So Friedel-Crafts reaction like everything is aromatic ring now. So take one aromatic ring, let us say benzene ring I am taking. So to this we are going to add one electrophile, something like methyl chloride or anything we are using in Lewis acidic condition. So finally we are making substitution. This electrophile comes into this ring and one of the electrophile from this ring will be goes out. It means let us say I have hydrogen over here. So this hydrogen is replaced as H plus. See, H plus is removed, E plus is incoming. So can I say it's substitution? Yes. So what substitution? Electrophilic substitution right now. So electrophilic substitution reaction is taking place and giving us final product something like this. So here we will be getting E in the place of H. That's it. This is the story happens here. Now since electrophile means it is an electron deficient site now, electron deficient species. Now the substrate has to be electron rich species, therefore reaction takes place properly. Okay. Now here if you see benzene ring we have, since it has electron cloud over there in this ring, so this electron cloud can accept this electrophile, electron deficient species easily and forms some product like that. But when it comes to aniline, yes, it is also electron rich species only by having this lone pair electrons, but you know, in Friedel-Crafts reaction we will be using something like AlCl3, like Lewis acid in anhydrous medium. So what is the purpose of this Lewis acid? In order to generate this electrophile. For example, I have methyl chloride, okay, I want an electrophile like methyl carbocation. For generation of this, I am using AlCl3. This is what? Anhydrous AlCl3 I am using. Since it is Lewis acid, the lone pair electrons of chlorine is donated to these and chloride ion goes out as AlCl4 minus, and from here we will be having methyl carbocation. This is our electrophile. So what is the purpose of Lewis acid here? To generate this electrophile. Now instead of involving the reaction with this methyl chloride in this case, whenever I use AlCl3 with this aniline, the lone pair electrons of this nitrogen will participate in reaction with this AlCl3. As this is acid, this is a base, it forms a Lewis acid base complex. Therefore, it will stop the further reaction. Therefore, this will not give Friedel-Crafts reaction. Hope this is also clear. Now this one will give, but this won't give. Now look at here, I told you, since we are adding, we are doing reaction with electrophile, we required our substrate to be, our reagent is electrophile, electron deficient. So our reagent, our substrate has to be electron rich now. See, but here we have electron withdrawing group. So since it is electron withdrawing group, it will decreases the electron deficiency in the ring and makes it electron poor or electron deficient. So I can say already electron deficient is there. If any electron rich species is there, reaction happens. But due to presence of this electron withdrawing group, nitrobenzene won't involve in this Friedel-Crafts reaction as it becomes electron deficient. Hope this is also clear now. Yes, let me move for the one more option here. So we have nitrogen with 4 atoms, 4 groups attached to it. See, 3 methyl groups, Me means methyl, okay, 3 methyl groups and 1 phenyl group, right now, and having nitrogen with positive charge. So I can say now this group is a strong electron withdrawing group. This is also like this, okay. So what it will do? It will withdraw the electrons towards the nitrogen side, and also what it makes? It makes electron deficiency in the ring. Therefore, attack of this electrophile will be decreases here. It means the electrophilic substitution does not takes place here in this 4th option also. So 2, 3, 4 are incorrect. Only possibility is there in this first option. You can go with Friedel-Crafts reaction only with option number 1. Hope this is also clear now. Yes, if it is clear, just click on the like button. Yes, yes, yes. So someone in the chat box, yeah. So just I hope it is also clear now. Yes, if anything is not clear, just ask me. Yeah, let me go forward. Here, so one last discussion on this. In electrophilic substitution reactions, what happens in electrophilic substitution reactions? What happens? Tell me. So first step is, there are 3 steps involved. So first step is what? In here, generation of electrophile. Second step is attack of this electrophile on these substrates like benzene, something like this, and forms a sigma complex in aromatic electrophilic substitution reactions. And the next step is, final step is deprotonation. So deprotonation in order to gain its aromatic nature, like back to it, like this. Okay, so these are the 3 steps you can have in this electrophilic aromatic substitution. If required more clear explanation of this electrophilic aromatic substitution, you can watch in the playlist of this channel. Okay, let me move forward with one more question. In which case SN2 reaction takes fastest? Tell me, in which of these SN2 reaction takes place faster? Yeah, so how this SN2 reaction takes place? See, ARSN2, it means aromatic nucleophilic substitution reaction takes place fast in which of these 4 options they are asking. How can you answer this? See, we have a benzene ring over like this. So with electrons like this, and here in all of these cases you are seeing something like chlorine, 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 and something like bromine. It means halogens must be present here now. So now what reaction they are saying? ARSN2, nucleophilic aromatic substitution. So some incoming nucleophile should come here and that should be substituted. This chloride should be substituted by this incoming nucleophile. See, we know nucleophile is electron rich species, right? So it is already having electron richness right now. So now in order to attack on this benzene ring, now see, already benzene ring contains high electron density by these pi electrons right now. So if nucleophile comes here, what happens? There will be electronic repulsions between the ring pi electrons and this incoming nucleophile right now. So if this electron density in the benzene ring decreases, nucleophile can easily attack. If it is increases, what happens? Their repulsions between ring pi electrons and nucleophile increases, reaction won't take place. So what is the main purpose we need to make here? We need to decrease this electron density in the ring. So how can we make it? So by putting some electron withdrawing groups at ortho and para positions. So some electron withdrawing groups like nitro group, if I substitute, what happens? That will withdraw this ring pi electrons and creates positive charge on this carbon right now, and nucleophile easily attacks at that positively charged carbon and the reaction takes place further. Hope it is clear. Now when this positive charge is created, we know this positive charge is more effective, or that carbon is more electron deficient when we have more electronegative atom is attached. So out of this chlorine and bromine, which is more electronegative? Chlorine is more electronegative than this bromine now. Therefore this will increases electron deficiency here. Attack of nucleophile easily takes place when it has more electron negative atom along with this electron withdrawing group. So I can say chloride ion, see, it is also having two nitro groups, it is also having two nitro groups. More the electron withdrawing groups, more is the reactivity, and out of this bromine and chlorine, which is more electronegative, chlorine is more electronegative, therefore that will further increases positive charge nature here right now. So reaction is more readily takes place in option number 2 than this 3. Hope the explanation is clear. Yes or no? Please tell me. Yes. Now I will be giving you one more question here. Just try to answer this. I have a compound like this, fluorine NO2. So these kind of questions usually you will be seeing in JEE mains also. Okay. So here I have nitro group here also, and the next option is something like this, fluorine, not fluorine here, chlorine, and NO2 here and NO2 here. Okay. So and along with this we also have one more bromine, NO2 here, NO2 here. So out of these 1, 2, 3 options, so tell me which is more reactive in this nucleophilic substitution reaction, aromatic nucleophilic substitution reaction. Write the order of these 3 compounds in the options. I will be looking into it. Okay, and you can see I already explained whatever the required information you need for solving this kind of questions. This is the previous year question also. There is a similar kind of question in the exam. Okay, now I just wanted to move forward. See, Hinsburg reagent. What is this Hinsburg reagent? What is this Hinsburg reagent? Benzene sulfonyl chloride is considered as Hinsburg reagent. Benzene sulfonyl chloride, SO2Cl2. So what is the structure exactly? Double bond O, and here phenyl ring Cl. So this is Hinsburg reagent. Okay. Now this benzene sulfonyl chloride they will mention, or Hinsburg test they will mention. So which will give, upon treating these amines with Hinsburg reagent, gives a solid which dissolves in alkali. So here you can remember, primary amines will react with this Hinsburg reagent, and they will be react with Hinsburg reagent. And see, what is this reactive means? See here we know primary amines means there is one alkyl group attached to the nitrogen like this, and 2 hydrogens right now. So now this one of the nitrogen atom and this chloride ion will goes out. so and forms something like this, SO, O, N, R and one H, something like this it will form. Now here if I further treat this with a basic solution, any of this basic medium, see in this Hinsburg reagent alkali is mentioned, dissolves in alkali. Since it is having one acidic hydrogen, this base can abstract this acidic hydrogen, that is what it can, this primary amines can react with this benzene sulfonyl chloride and the respective product can be soluble in the alkali medium. This is a thing you can remember. Whereas if I take the other secondary amine, so I am taking secondary amine, so this can be reactive, therefore it makes primary amine to dissolve in the alkali medium after reaction with Hinsburg reagent. Now here I am taking this benzene sulfonyl chloride with secondary amine. So secondary amine here I have. So what happens? They will be reacting and remove this HCl. So we will be having a product like this. See, in this case there is no acidic hydrogen as like in the first case. Therefore, this can't be dissolved in the this secondary amine. The product formed from the secondary amine after treating with Hinsburg reagent cannot be dissolved in the alkali medium. Only primary amines can dissolve. So out of these four options, so tell me which is primary amine. Here we have only option number 2, we have primary amine. So that can be dissolved in the aqueous alkali medium. Hope this is also clear now. Yes. Okay, let me move forward. Yeah, which of the following amine will give the Carbylamine test? So tell me out of these four, which will be giving Carbylamine test? Yeah, so look at this, Carbylamine test is given only by primary amine, something like this, RNH2 I am writing. I am treating this with chloroform CHCl3 in basic medium. Okay, so basic medium, they will be giving some product like this. Remove these two hydrogens and chlorines from here and forms RNC type of product. So these are called cyanides, isocyanides. What is that? Isocyanides. They will be having foul smell that indicates what? The given amine group is what? Primary amine. Given functional group is primary amine. Okay, so now Carbylamine test is given only by primary amines, so that you can use this Carbylamine test to identify primary amines. So just identify which will give this Carbylamine test. So it should contain a group like this, NH2 should be there. Okay, this kind of group should be there. So along with some R or aryl group. See, this is not having that, this is also not having, this is also not having. Only option 4 is the primary amine, that is aniline here, can give Carbylamine test. Okay, all aliphatic aromatic amines will give this, primary amines will give this, aliphatic aromatic primary amines will give this Carbylamine test. Hope this is also clear. Right now let me move forward. Yes, so here I have one more question. So if you look here, we have amide group treating with KOBr. Either they may give KOBr, or they will give Br2 NaOH or KOH, something like this. Okay, so what happens in this reaction? So this reaction is called Hofmann bromamide degradation. What is that? Hofmann bromamide degradation. So it is for preparation of primary amines. For what? Preparation of primary amines. So what you need to do? Primary amine I told now. So keep it as it is. See, I am writing NH2 here. So what you need to do is just remove this CO group, remaining attach as it is. Like this phenyl group you attach to this nitrogen, you will get a product of this kind, like this. Yes or no? Yes. So where do we have this option? So phenyl group I can write PH NH2. So we have option number 2 as the answer, which is corresponding to this question. So that is our answer. Hope this is clear. Now I am giving you one question. I am giving you one question here. So take this CH3, CH2, CO, NH2. I am treating this with KOBr. So what is the product formed? I want its product name in the chart box. You can write here. Okay. Hope the session is really went well, and if you have anything to be discussed or any topic is there from your side to be discussed in the class, you can write in the chat box, we will definitely discuss. Okay, so thank you for watching, stay connected with us. Okay, thank you. Wow, wow.